Okay, ladies and gentlemen, here's a quick, not super quick, but quick review for tomorrow's SBQ. Remember, it's going to be on function types. Remember, we've been looking at graphs of functions with our x-axis and our y-axis. Remember, our x-axis is the independent variable. It determines what goes on. You change the x, it will determine the y, who is the dependent variable. The domain is the range of x values available to you. So in this case, x would be between 3 and 9. That's the domain, right? Good. The range is the y values, the lowest y value to the highest y value. And y in this case would range between 4 and 8. Remember, to be a function, you have to pass the vertical line test. And the definition is, right, for any x value, there's no more than one y value. There can be no y value, but there has to be at least one, and I should fix this because these are endpoints. Let's draw them as such. Terrible endpoints, but they're still going to work. Okay, in terms of function types, the first one we talked about was polynomial. I didn't ask you to memorize the equation for it. Just remember, it's a combination of one variable and various coefficients and exponents. And 1. The order you put them in doesn't matter. It's polite to write them in decreasing order. There can be a constant at the end. And remember, these graphs are smooth. They're just going to have up and downs, no breaks, no anything like that. Next function type is a quadratic, where y equals ax squared plus bx plus c. And remember that a cannot be equal to 0, otherwise it's a lion. It's line. No, still not funny. Sorry. This one is a is greater than 0. This one is a is less than 0. Makes the graph happy or sad. Determines the concavity. Moving on from quadratic, the two that sometimes get mixed up are power and exponential. Exponential has an x already in it. X in the exponential. Sorry about that. In an exponential, the x is in the exponent. So this is equal to y equals ab to the x. In the power function, if I want to plug a power cord in, I usually have to reach down to plug it in. That x is going to be down low. Y equals ax to the b. The power function will either pass through the origin, or it will not touch anything on the y-axis. It'll be nice even in that corner. For the exponential function, it will always, always, always pass through the y-axis. If it's passing through the y-axis and it's making a direction, it's going to be an exponential function. Those are the two that get most commonly mixed up. Direct variation and inverse or indirect variation. Direct is y equals kx, meaning as x gets bigger, y gets bigger. Inverse is y equals k over x, or y equals kx to the negative 1. They're the same equation. And this one, as x gets bigger, y gets smaller, and vice versa. A direct variation is just going to be a line through the origin. So if you see an equation with a line and it passes through the origin, oh, I left off line. I'll get to that in a second. It can be either equation. Inverse or indirect are going to be an asymptote in the first quadrant. It'll be nice and smooth and even. Let me move over here. I left off linear, L-I-N-E-A-R, which is y equals ax plus b, or y equals mx plus b, where m is the slope and b is the y-intercept. And a linear equation can appear in any part on the graph. Now I'm going quick, but I think it's okay. A rational algebraic equation is going to have a ratio in it. It's going to be one polynomial over another polynomial. And rational algebraic equations can have breaks in them whenever the bottom is 0. So when x is equal to negative 2, this rational algebraic equation would have a break in it. So it might look like that. You'll be able to identify the rational algebraics as opposed to the inverse variations or the power functions. The indirect or inverse functions and the power functions are going to be nice and even in the quadrant, always. Where the rational algebraic expressions are going to be a little wacky. They may be all over the place. You'll know that's a rational algebraic expression. Okay, I did it in under 5 minutes. There's your review. I shall talk to you later. Goodbye.